Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad bin Muhammad RASHIDI and the number is DD220027. I will start with the introduction. Dynamic is a branch of physical science that studies the motion of body and objects in relation to physical force, mass, momentum, and energy. It analyzes Newton's laws of motion and is a subfield of classical mechanics. Dynamics involves analyzing systems of single or multiple interacting bodies. It is used to calculate the motion of objects in linear or curved paths, such as determining the velocity of a car after impact. Downhill motion combines with tensional and translational motion and is a common scenario in everyday life. A case study involving a car moving downhill at an angle will be conducted to study the kinetics of a rigid body and measure the car acceleration as a function of the angle. The experiment aims to establish an empirical relationship between the angle and acceleration, compare the result with the theoretical prediction, assess measurement precision and reliability, identify discrepancies or sources of error, and deepen understanding of fundamental physical concepts related to downhill motion. Okay, so I will continue with the objective. For the first point, to find the acceleration of the car downhill, driving the hill using the kinematic of the rigid body. The second point, to determine the final velocity of the car as it moves downhill without the slipping using kinematic and the principle of conservation of energy. The last point, to identify the difference in acceleration and velocity between cars of various sizes. That's all for me. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh and greetings. My name is Muhammad FARHAN JAMALUDDIN. Number matrix DD20032. So today I would like to talk about the case study of our mini group project. So in human daily life, there are various applications that are used by about dynamics. Among them is when a vehicle moves downhill. With this application in our daily life, we can understand more about the world. A simple occurrence like the car moving downhill has many factors that account to the motion. As we look further into the details about the situation, we can see that Newton's second law of motion is applied during the action, which means we can conclude the formula is force equal to mass times acceleration. With the right analysis, we can almost precisely determine the car acceleration during the descent down the hill. It stops it at the bottom of the incline and the amount of kinetic energy it contains as it transfers its initial potential energy at the top of the hill in accordance with the conservation of energy principle. As for accretion, do the method of the vehicle have different kinetic properties during its action moving downhill? This mini project intended to make a case study about the difference in kinematic properties of a rigid body in different masses. This is where we conduct an experiment for a car with different masses moving downhill by making the other variable constant, which is force and acceleration. By doing this action, we can easily understand the kinematic properties like acceleration and velocity as it moves down an inclined plane. Okay, next for methodology, our team came up with this straightforward drawing to better understand how an object mass impact its kinematic as it rolls down an inclined plane. We draw an inclined plane with a fixed angle of incline 45 degrees and a fixed distance of 5 meters. We then choose three different masses of car which are 5 kg, 10 kg and 15 kg. The distance of the car moves toward downhill at the angle of 45 degrees we keep a constant and calculate kinetic energy and potential energy of the car. Okay, next I will talk about the formula used in this mini group project. First of all is Newton's second law, which is force equal to mass times acceleration. And then acceleration, which is final acceleration, final velocity equals to initial velocity plus 2as. So the v2 is equals to final velocity, po is initial velocity, and as is stand for acceleration times distance. So for kinetic energy, so ke equals to 1/2 mv squared. Mv squared stand for mass times velocity. So lastly is potential energy, which is PE equal to MGH. MGH stands for mass time gravitational acceleration time height. That is all for me. Thank you.
Assalamualaikum. My name is FAUZAN. So today I'm gonna present a calculation. So for the calculation part, the bulk mass change which 5 kilo, 10 kilo and 15 kilo. While the angle of the plane tilt is constant, which is 45 degree. The plane has a metal surface with a coefficient of friction of zero point 0.5. The distance bulk has moved is from 0 to 5 meter. The height of the bulk is start at 3 meter. So for the first one is we need to calculate the normal force. The normal force we will use the Newton's second law, which is state F is equal to ma. So when m is 5 kilo, we substitute the m as a 5, and then we're gonna get 34.68 Newton for 10 kilo and 15 kilo. The same step we have applied, which is to substitute m as 10 and 15 kilo. Then we're gonna get for 10 kilo we get 69.37 Newton, and for 15 kilo we get 104.05 Newton. So we're gonna continue with the acceleration. To calculate acceleration in x direction, we will apply the Newton's second law, which state F is equal to ma, which is the A is unknown. So when we apply the 5 kilo and the normal force we get before, and we're gonna get for 5 kilo we get 3.47 meter per square s square, and for 10 kilo we get 3.47 meter per square, and the same as 15 kilo we get 3.47 meter per square. This will compute this as acceleration constants. And for velocity, we know that the acceleration is constant. Then we're gonna use equation v square is equal to v naught square plus 2a s, where the initial velocity is equal to 0 and the distance is 5 meter. So when we apply the equation, we get v for 5 kilo is 5.x9, and we can see the result is the same because the acceleration is constant, and we know now the velocity is also constant. Alright, we move to the next part, which is kinetic energy. And we can get kinetic energy by using the equation of kinetic energy is equal to 1 over 2 mv square. And we get mv square. We have get before, and the same velocity we have used. And you can see the result is on the kinetic energy. You can see 1, 2, and 3. And for potential energy, we can use PE, which is equal to mgh. When m is equal to 5 kilo, we get 147.15 joule. For 10 kilo, we get 294.3 joule. And for the last one, we get 441.45 joule.
Okay, my name is MOHAMMAD. I want to present about the analysis of this project. Firstly, normal force when the mass of an item increase while the acceleration of one remain constant, the normal force acting perpendicular to the surface increase as well. Second, acceleration and velocity. Despite change in object mass, acceleration and velocities stay constant throughout. As a result, the mass of the item has no effects on the values of velocity and acceleration. Third, kinetic energy. Due to continuous acceleration as velocities, it may be inferred that the more mass an object has, the more kinetic energy can be stored within its next impulse. Similar to kinetic energy, an object's mass can influence the overall impulse that occur throughout time. As the object's mass increase, the impulse increase due to a steeper inclination and a smoother surface. Lastly is a friction force. Friction force is the opposing force that occur when two surfaces come into contact with each others and move in the same or opposite direction. Friction is a force that opposes or resists the motion of two objects that come into touch with each others and slide against each other.
Assalamualaikum. My name is Muhammad IMRAN bin Muhammad HAIRI and my metric number is DD220041. For discussion, our group opted to analyze the kinematic of a rigid body in the example of a car going down a hill at a constant angle in this case study. One of the primary explanations for this case study is the data accessibility and efficiency in obtaining normal force, acceleration, velocity, and kinetic energy. It's a comprehensive experiment that's rather easy to investigate. The primary purpose of this case study is to meet the first goal of this experiment, which is to figure out the acceleration of a rigid body, which is a car traveling down a hill at a given angle. Using the rigid body's kinematic formula, we can readily quantify energy conservation due to the car's form because friction is fairly low. The ultimate aim is to calculate the difference in acceleration and velocity between a car's three different masses. As mentioned earlier, we had set several conditions for our case study. In the beginning, the plane's angle is fixed at 45 degrees. To determine the amount of acceleration and velocity of each the three cars, the mass of the cars was set to 5 kg, 10 kg, and 15 kg respectively, and the plane provided a coefficient of friction of 0.5. Based on the calculation, the acceleration is 3.47 meter per second squared and the velocity is 5.89 meter per second. As a result of this case study, we explore the kinematic of a rigid body and how it impacts the cars.
Okay, next I want to present about the conclusion of this project. In conclusion, after we went through this project, we were able to know the kinematic or kinetic of rigid bodies of complex in engineering problem in real application, and were able to identify the force involved. We may conclude from the case study and computation that changing an object's mass has no effect on its velocity or acceleration. For kinetic energy, however, we may derive that the greatest the object mass, even at constant acceleration and velocities, the greatest the kinetics energy store inside the item. Furthermore, the mass of an object can influence the total impulse that occur over time because as mass increase, the inclination becomes steeper and the surface becomes smoother. As a result, a large mass object will have a highest impulse value than a smaller mass object. We may compare the result and makes recommendation by setting three distinct beginning location for the distance of an object down an inclined plane or the position or situation of a car moving down a hill. As a result, we can see the acceleration and velocity difference at each point along the baseline distance. Thank you.